So in the last segment, I hope you recognize that the product A times B was the same as the product of the GCF and the LCM. And we should know that we can't conclude that something is always true based on one example. Okay, so examples don't prove things, all right? And that's something we've talked about quite a bit. But we can prove that this would always happen because if I have two numbers A and B, and so I color coded them, and I found the GCF, when I find the GCF, I take the base with the lowest power. Okay, so I would take the lowest power on the A. So every power is either the lowest or the highest. Or they could tie, at which point I just randomly assign them, to go to the GCF or the LCM. Okay, but for my GCF, I took these factors, right, because they were all my lowest, or like I said, I just picked this one. I sort of picked it to balance the red and green color, not for any mathematical reason. And then notice for LCM then, the rest of the remaining factors that aren't underlined are the powers, the bases with the highest power. All right, and those go into my LCM. So this would always be true. And so this is going to lead us to a nice rule, one of my favorite rules for finding an LCM that we're going to talk about probably next Tuesday. And let's try an example with this right now though. So copy this down and then pause your video for a minute and try this example. So we have the GCF of n and 75 is 15. And the LCM of n and 75 is 1800. Okay, find n. All right, so pause the video and try this. Okay, so coming back, we should recognize that the product of any two numbers, right? So if I multiply n and 75, the product of the two numbers is the product of the GCF and the LCM. Okay, so here's the GCF, here's the LCM. So if I multiply the GCF and the LCM, that has to equal the product of the two numbers. All right, so I would divide both sides by 75, and I get n equals 360. All right, so like I said, we're going to elaborate on this rule and some of the interesting things that it tells us. We'll look into that more on Tuesday. So anyway, something else that I posted for you, I posted this document that says think about these. All right, because what I want you to notice is that sometimes the LCM of two numbers is just the product of the two numbers. Okay, but other times not. So I remember when my daughter first started adding fractions, and she came home and told me, and she said, Mom, they told us we had to find the least common multiple. She said, but I noticed that the least common multiple is just means you multiply the two numbers. All right, and that's because she was working with things like thirds and fifths. Okay, so if you were adding thirds and fifths, then sure, the least common multiple is just 15, right? Or she was doing like halves and fifths, right? So then the least common multiple is 10, or halves and thirds, least common multiple is 6. Okay, but as soon as you start doing something like fourths and sixths, the least common multiple is not 24, it's 12. Okay, or if you have thirds and sixths, right? I could say a common multiple is 18, but the least common multiple is 6. Okay, sometimes students say things like, okay, if the numbers are both prime, then the LCM is just the product. Okay, and that would be true, like 5 and 7, the LCM is 35, but sometimes the LCM is just the product when they're not both prime. Like look at 8 and 9. Neither of these numbers are prime, and yet the LCM is the product, 72. 4 and 25, neither of those numbers are prime. LCM is the product. 6 and 35, so here the LCM is the product. So every time the LCM is just the product, which happens here, 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 and here. Oh, and here too. Okay, what do these numbers have in common that makes them different from the other pairs of numbers, right? The ones in the checked row, what do these have in common that the ones in the unchecked row do not have in common? What property? All right, so I want you to look at that and try to figure that out. And the answer will be in the next lecture. And one more thing that I want you to do for today. So there's going to be some participation, and there is some suggested homework for today that you have to do. If you want to not have to take exam 3, you have to keep up with the suggested homework. You'll be able to work more on your collected homework. And then one more thing that I want you to do to lead up to the next lecture is let's go back to our S20 numbers for a minute. Okay, and let's consider this number. So I want you to change this into base 10, this number and this number. Change this into base 10. And what we're going to look at with S20 is, are these numbers even? Why am I not using a text box? Even or odd? All right, are they even or odd? So you'll probably look at the last digit and say, well, the triangle, that's a 3, so this must be odd. And all right, that's a 4 in the last digit, this must be even. Okay, but change these into base 10 and see what you notice.